Hello, welcome to GP Podcast. Today, we're going to journey into a hidden universe, a tiny city built with an impossible level of precision, right inside the device you might be holding in your hand this very second.
So how in the world are billions of these microscopic switches packed into a chip no bigger than an ant? To get our heads around that, we have to travel from a scale we understand down to a world that honestly just defies imagination. Let's dive in.
All right, so our journey starts with something we all know, a smartphone. But to really get what makes it tick, we have to look inside. And what we find in there, well, it's anything but simple.
Okay, get ready for this. Your average smartphone is packed with about 90 billion transistors. That's billion with a B. These are basically the tiny electronic switches that are the building blocks for, well, everything in our modern world. Now, if we could zoom into just one of the main chips, let's say the CPU, you wouldn't see some flat, boring surface, no way. You'd see this towering city of circuits, a crazy 3D maze of wires stacked 17 layers high, all separated from each other, just zipping data all over the place. But it's down at the very foundation of this city where things get really, truly wild. This is where the transistors live, and they operate on a scale that is just impossibly small. A key part of each transistor, called the channel, is only 36 nanometers wide. To put that into perspective for you, a single human hair is more than 2,000 times wider than that little channel. So the question is, how on earth do you build something that small?
Well, the answer is in a process that's, less like regular manufacturing and a lot more like baking the most complicated, high-stakes cakes you could ever imagine.
Just think about that for a second. This recipe takes 3 months to make and has almost 1,000 steps. The precision has to be absolutely perfect. One tiny mistake, even a single speck of dust, can completely wreck an entire batch of chips that are worth hundreds of thousands of dollars.
So, this whole 80-layer structure is built by just repeating a core 4-step process, again and again, just with a different pattern each time. First, you add an insulating layer. Then, you use a special stencil and UV light to stamp a pattern onto it. After that, you chemically etch away the parts you don't need, and finally, you fill in the gaps with copper and polish the whole surface perfectly flat, so you can start the next layer.
Okay, so we have this insane recipe. But what about the kitchen? Well, we need to zoom way out, to a gigantic environment that they call a semiconductor fabrication plant, or just a fab for short. And this isn't some workshop. It's a massive, unbelievably clean room where slices of silicon, called wafers, are carried around by robots from one enormous machine to the next. For 3 whole months, these wafers travel on this complex journey between hundreds of different tools, each one performing another step in our 1,000-step recipe. The hundreds of tools inside, which each cost millions of dollars, by the way, can be broken down into 6 main jobs. You've got tools that make the stencils, tools that add material, tools that remove material, some that change the silicon itself, and, this is absolutely crucial, tools that do nothing but clean and inspect the wafer at every single stage. And the money involved is just staggering. The most important tool of all, the one that patterns the layers by shining this extreme ultraviolet light through the stencil, it costs $170 million for one machine. So we've seen the recipe and the incredible kitchen where it all happens. Now let's pull back and look at the whole story, the complete journey from raw sand all the way to the silicon brain that powers our digital world. The journey actually begins long before the fab. It starts with quartz sand, which gets refined into these huge, pure silicon crystals. Then they slice them up into these perfectly polished wafers. And even after the 3-month marathon inside the factory, the process still isn't over. See, after all that work, not every single chip on the wafer comes out perfect. So they test them all, rigorously. The ones that are flawless become the top-tier products, like an Intel Core i9. But the chips that have tiny, non-critical defects, well, they become the lower-tier products, like an i7 or an i5. It's a clever sorting process called binning.
This entire monumental effort basically transforms a slice of fancy sand worth about $100 into hundreds of chips that are collectively worth $100,000. That means a finished wafer is, quite literally, 10 times more valuable than its weight in gold.
For decades, our entire modern world has been built on this incredible process of making things smaller, faster, and more powerful. Which leaves us with a final, really critical question. The engine of all our progress has been making things smaller. So, what happens when we finally hit a physical wall, and we just can't make them any smaller?
If you like this explainer, subscribe, leave a like, comment on what you liked most, and share the video. Your support really helps us create more content just like this.